Hello everyone, hope you all are doing good. I am Anjana from LearnoHub, the free learning platform where you can study math, science and SST absolutely free at learnohub.com. In today's class, we are going to discuss ICSE Class 10 Maths Chapter 14, Equation of a Line. We have already discussed in the previous classes, equation of a line, slope, gradient, inclination, slope of parallel and perpendicular lines and collinear points. If you haven't watched that video, go watch them first. Today, we will be discussing few more concepts with examples and solve many questions from exercise 14C. Hope you all are ready. Be ready with your pen and paper. Let's solve questions together. X-intercept and Y-intercept. Here we are taking the coordinate axis, x-axis and y-axis. This is origin. What are the coordinates of origin? Yes, origin has coordinates 0, 0. X coordinate is 0 and y coordinate is 0. Let us mark some points. 1, 2, 3, 4, 5 along the positive x-axis, along positive y-axis. 1, 2, 3, 4, 5, 6. Along the negative x-axis, -1, -2, -3. Along the negative y-axis, again -1, -2. Some points we are marking. Now, consider a line. So, I am taking a line. This line passes through the x-axis and y-axis. Here, this is a point where the line cuts x-axis and this is a point where the line cuts y-axis. What are the coordinates of this point? Let us name this point as A. What are the coordinates? This point lies on x-axis. A point that lies on x-axis will be having the y-coordinate or the ordinate equal to 0. Y-coordinate is 0. What about x-coordinate? Distance from the origin along the x-axis. Here we have 3. Okay, 3 units. So, the x-coordinate or the abscissa is equal to 3. Okay, so for the point A, we have coordinates 3, 0. Now, when you consider this point, a point that lies on y-axis will be having the x-coordinate 0. Yes, so this is my point B. X-coordinate is 0. What about y-coordinate? Distance along the y-axis from the origin. What is the distance it has travelled? It has travelled a distance of 5 units. Therefore, the y-coordinate or the ordinate is 5. Okay. So, we got the coordinates of points A and B. A lies on the x-axis and B lies on y-axis. Here, it is clear that the line cuts x-axis at point 3, 0 and it cuts the y-axis at point 0, 5. So, what is x-intercept and y-intercept? This distance or the abscissa or the x-coordinate of point that lies on the x-axis is the x-intercept. Okay, in this case, x-intercept, the point where the line touches the x-axis is equal to, x-intercept value will be equal to 3. Okay, x-intercept value is 3. And the line meets at a point on the y-axis. The ordinate of this point or the y-coordinate of this point is called the y-intercept. Y-intercept is equal to, here in this case it is 5. Okay, so understood what x-intercept and y-intercept is? Intercept made by the line on the x-axis is called x-intercept. This is our line and it makes an intercept at this point on the x-axis. So, this is called x-intercept. Intercept made by the line on y-axis is called the y-intercept. Got it? Y-intercept is the point where the line cuts the y-axis. Okay. Now, let us consider two other points. 4, 0 and 0, 6. I have taken 2 points. Mark these points on the coordinate axis. 4, 0. 4, 0 is a point that will lie on the x-axis because the y-coordinate is equal to 0. So, this is a point 4, 0. What about 0, 6? Here the x coordinate is 0 and the point lies on the y-axis. 0, 6. Here we have 0, 6. Now I am drawing a line which passes through these 2 points. I am drawing a line which passes through these 2 points. This is my line. Now it is clear that the line cuts x-axis at one point and cuts the y-axis at one point. Then what are the x and y coordinates? Here the x coordinate of this point is 4 and the y coordinate is 0. Here the x coordinate is 0 and y coordinate is 6. Okay, then we can write what x-intercept and y-intercept are. X-intercept. What is the x-intercept here? We have to check the x coordinate of point where the line cuts the x-axis. Here the x coordinate is 4. Therefore, the x-intercept is equal to 4. What about y-intercept? Consider this point. So, this is a point where the line cuts or meets the y-axis. For this point, we have to take not the x coordinate but the y coordinate. Here y coordinate or the ordinate is equal to 6. Therefore, y-intercept is equal to 6. Now, you understood what x-intercept and y-intercept are. You know to find when a line is given what the x-intercept and y-intercept is. So, y-intercept is usually represented using the small letter c. Okay. Remember these things. Now we will be discussing the various forms of the equation of straight lines. 3 forms we are going to discuss: slope-intercept form, 2-point form and the point-slope form. The first one is slope-intercept form. As the name suggests, slope-intercept form is used when the slope is also known as gradient, and intercept on the y-axis are given. Okay, 2 things. One is slope and the second is the intercept on y-axis. Here consider our coordinate axis. I am drawing a line which meets the x-axis and y-axis. So, I am taking this point as A. That is the line cutting x-axis at A and the line cutting the y-axis at a point B. Okay. Here we have origin. Now, I am considering some general point P of coordinates x, y. Okay. Here the coordinates of point P are x, y, which means this distance it travels from the y-axis is x and this distance it has travelled from the x-axis is y. Okay. So, here when I draw perpendicular, I will be getting this total distance as y. Okay. Now, what is this? This is our y-intercept. Yes, that is we can call it as C. This distance will be C. Y-intercept is a point where the line cuts the y-axis. So, you will be having y-intercept here and this distance is C. Now, if I draw a line parallel, I am drawing a line parallel to the x-axis and marking a point R. To find the slope, let us take the inclination as some theta. Theta is the inclination. Okay. Using theta, we can find slope. We know all this. Now, if this angle is theta, we have a line parallel to x-axis. For parallel lines, when a line cuts these parallel lines, we will be having corresponding angles equal. Now, these 2 lines, BR and x-axis are parallel to each other and the line which we have drawn is a transversal. Therefore, this angle should be theta. Okay. We have slope M is equal to tan theta. Slope M is equal to tan theta. Now, here we know this distance PR will be equal to PR is equal to Y minus C. This total height is Y and this height is C, which means PR will be equal to Y minus C. What about this distance? This distance is X, that is the X coordinate of point P. Okay. Now, when I am taking tan theta, we know tan theta is equal to opposite side divided by adjacent side. Here, what is the opposite side for this angle? This is the opposite side. Yes, that is PR. BR divided by, this is what our adjacent side is, that is angle touching side, okay, which is BR equal to PR is Y minus C divided by BR is X, okay. So we have slope M is equal to Y minus C divided by X. Now what I am going to do is I am going to cross multiply this, okay. What do we get? On cross multiplying, we get Mx is equal to Y minus C. We need in terms of Y. For that I am taking this minus C to the opposite side. Mx plus C is equal to Y, or Y is equal to Mx plus C. Okay, Y is equal to Mx plus C. So this is the slope intercept form. Got it? This is slope intercept form. We'll be having Y is equal to Mx plus C, where X and Y are the coordinates of a general point considered. M is the slope and C is the y-intercept. Okay. Second one is point slope form. A point will be given and the slope is not. In that case, we can use the point slope form when the slope of the line and a point in it are given. So here again we have the coordinate axis, x-axis and y-axis. This is our origin. I am considering a line. This is my line. Here I am having point A. Now considering 2 points. Okay. So this point P of coordinate x1, y1 is given. Okay. We'll take some general point Q of coordinates x, y. Here we have an inclination angle theta. This is our inclination. Now from this P, if I draw a perpendicular, this distance will be x1. Yes, this small distance is x1. Okay, from Q, if I draw a perpendicular to the x-axis, I'll get this total distance. This whole distance will be equal to x. This whole distance is x. Okay. Similarly, here I am drawing a perpendicular from point P to the y-axis. This total distance will be equal to y1. This part is y1. Okay. Now from Q, I am drawing a perpendicular to y-axis. Then this total distance will be equal to y. Now I am drawing a line which is parallel to the x-axis from this point P and marking the meeting point as R. If this angle is theta, we have PR parallel to x-axis. Okay. Since this line PR is parallel to x-axis, the line which we have taken will be a transversal. So when a transversal cuts a pair of lines, parallel lines, we will be having corresponding angles equal. So if this angle is theta, then this angle will also be equal to theta. Okay. This angle will be theta. Now here, what is this distance? The total height is y and this part is y1, which means this will be equal to y minus y1. Okay. What about this part? Here the total distance is x and this small part is x1, which means this part will be equal to x minus x1. Now we have slope M is equal to tan theta and that is equal to, what is tan theta? Opposite side divided by hypotenuse. Opposite side by hypotenuse. Here M is equal to tan theta. What is opposite side? Here we have angle theta. Opposite to this we have y minus y1. That is this QR. QR divided by adjacent side is PR. PR. That is equal to QR is y minus y1 and PR is equal to x minus x1. Okay. Now we have M is equal to y minus y1 divided by x minus x1. Next step, we are going to take this x minus x1 to the left hand side. M into x minus x1 is equal to y minus y1. On rearranging this, we get y minus y1 is equal to m into x minus x1. Okay. So, this is the required equation. That is the point slope form of equation of a straight line. Got it? Here we need slope value, that is m should be given, and the coordinates of any one point. Here we have taken point P of coordinates x1, y1, and we have considered a general point, that is Q of coordinates x, y. Okay. When you put some values, if you have coordinates for the point P, let the coordinates of point P be 2, 3. And our slope m is equal to some 1. In that case, in place of x1, y1, we are going to substitute this 2 and 3. Then the equation of line will be y minus, here y1, in position of y1 we have 3, is equal to m is 1 into x minus x1 is 2. On rearranging this, we will be getting the equation of line. Clear? So, here we need a point and the slope. In the previous form, we needed only the slope and the y-intercept. Understood? Next, the third one is 2 points form. As the name suggests, 2 points will be given. Neither the slope will be given nor the y-intercept will be given. Instead, 2 points will be given. When the coordinates of 2 points of the line are given, in that case. So, here I am considering line. Okay. So, this is A. Now, take 2 points P, Q. Coordinates of P are given, that is x1, y1, and that of Q is also given, which is x2, y2. We know the coordinates of the 2 point which lies on the line. Okay. With this information, how can you bring an equation for the straight line? Now, when I draw perpendiculars from point P and point Q, I will be getting this distance as x1 and this whole distance as x2. Okay. Similarly, drawing perpendiculars to the y-axis. Here we will be getting, for the point P, this total distance will be y1. And for the point Q, when I draw a perpendicular, this total distance will be equal to y2. Yes, we will be having an inclination angle theta. Yes. Now, what I am doing is, from this point P, I will draw a line parallel to the x-axis. As usual, we used to do this. And this is R. Okay. Now, we have this part is equal to, here the total height is y2 and this portion is y1. y2 minus y1. Here we have this total distance x2 and this more portion x1. So, this distance will be equal to x2 minus x1. We know to find the slope. What is slope? M is equal to tan theta, and here that is equal to opposite to angle theta. Here this angle is theta. When lines are parallel and we have a transversal, we will be getting this angle also equal to theta. Opposite to theta, we have y2 minus y1. So, this is y2 minus y1 divided by, here we have x2 minus x1. Adjacent side x2 minus x1. So, slope m is equal to y2 minus y1 divided by x2 minus x1. In case of 2-point form, first we are going to find the slope m. Okay. Now, we have the normal form, that is y minus y1 is equal to m into x minus x1. Here we are going to use this. That is for the point slope form. The same equation we will be having for 2-point form. The difference is that in point slope form, the slope will be given. Here we are finding the slope first. How to find the slope? If you have the coordinates given, finding the slope is using this form, that is y2 minus y1 divided by x2 minus x1. We got the slope value. Okay. Then take any one point. Either you can take the point P or the point Q. One point we need, and this x and y are the general coordinates of the general point. From this you can find the equation of line when 2 points are given. Understood? Let's take an example. Here, let us consider x1, y1 is equal to 2, 3 and x2, y2 is equal to 4, 6. What is the slope then? Slope m will be equal to y2 minus y1 divided by x2 minus x1. Here y2 is equal to 6 and y1 is equal to 3. 6 minus 3 divided by x2 minus x1. Here x2 is 4 and x1 is equal to 2. That is 6 minus 3, 3 divided by 4 minus 2, 2. Okay, we got the slope m is equal to 3 by 2. After getting slope, what else we need? We need any one point. Either you can take the point with coordinates x1, y1 or with x2, y2. Usually we take this x1, y1 point. Okay, there is no mistake if you take this point as well. So here we have coordinates 3, 2, 3. Putting in this, we get y minus y1. y1 is 3 is equal to m we have determined, that is 3 by 2 into x minus x1 is 2. Okay. On rearranging this, we will be getting the equation of the straight line. So, you have to remember this point. In this case, slope will not be given. Neither inclination will be given. Only thing is 2 points given. From these 2 points, we are finding the slope. In the first case, in the first form of the equation of straight line, we had the slope directly given. In the second case, what was given? Slope and point was given. Here slope will not be given. We need to find slope with the 2 points. After that, the same thing, that is point slope form. We are just substituting the slope value at any one point. Okay, the format is same. We have one more concept to discuss, which is equally inclined lines. Equally inclined lines means the lines which makes equal angles with both the coordinate axes. Here we have the coordinate axis, x-axis and y-axis. I am considering a line. This is my line AB, another line CD. Okay, AB has an inclination of 45 degree with the x-axis, that is, it has moved 45 degree with the x-axis. Okay, now what about CD? CD is making an angle of minus 45 degree. Here, when you are measuring in the clockwise direction, you have to take it negative. Here we have measured in the anti-clockwise direction, therefore angle is positive. Here we are measuring from the left side of the line. This is from the right side of the line. Yes. Here we are measuring with respect to the left side of the x-axis. Therefore, our angle should be minus 45 degree. Now, what is the slope in each case? Slope of AB, m is equal to tan theta. Here, angle theta is equal to 45 degree. That is tan 45 degree. We know x-axis is perpendicular to y-axis. Then this angle also will be equal to 45 degree. Similarly, this one will be minus 45 degree. Tan 45 degree, what is the value of tan 45 degree? Tan 45 degree is 1. Now, what about the slope of CD? Slope of CD, m is equal to, again, tan of the angle theta. Here the angle theta is minus 45 degree. Tan of minus 45 degree. What is tan of minus 45 degree? We have studied sin of minus theta is equal to minus sin theta. Similarly, tan of minus theta is equal to minus tan theta, equal to minus tan 45 degree, and the value is tan 45 degree is 1. Therefore, we get minus 1. So, for equally inclined lines, we will be getting slope of the first line 1 and the slope of the other line minus 1. Here, they are inclined at an angle of 45 degree. With x-axis, this AB is at 45 degree. Again, with y-axis, line AB is at 45 degree. Similarly, when you consider CD, with x-axis, it is making minus 45 degree angle, and with y-axis, it is making minus 45 degree angle. Okay. Here, 45 degree is measured in the anti-clockwise direction, and here 45 degree is measured in the clockwise direction. Therefore, it is negative. Understood this? Let us take an example to clearly understand the concepts that we have discussed. Find the equation of a line, first one, whose inclination is 45 degree and y-intercept is 5. Here inclination and y-intercept is given. Second, with inclination equal to 60 degree and passing through -2, 5. Here a point is given and the inclination is given. And the third one, passing through the points -3, 1 and 1, 5. 2 points are given. Let's take the first one. We have all the concepts with us. Just we need to apply. So the first one, inclination is given. Inclination represented as theta is equal to 45 degree. Using inclination, we know to find slope. We have studied in the previous class. Slope is equal to, slope is represented by letter M, and slope is equal to tan of inclination, that is tan theta. Here what is theta? Theta is 45 degree. Therefore, slope M is equal to tan 45 degree. What is the value of tan 45 degree? 1. Yes. So, M is equal to 1. This is our required slope. We got the slope, and what else is given? Y-intercept is given. Y-intercept is represented by the letter C. Y-intercept C is equal to 5. Now, we can write the equation of line. We have Y is equal to mx plus c. Here we have determined the value of m, that is slope, and the y-intercept c is already given, which is 5. Substituting, we get y is equal to mx 1 into x plus c value is 5. Therefore, the equation of the line with slope 1, inclination 45 degree and y-intercept 5 is y is equal to x plus 5. So, this is the required equation of our line. Okay. Now, we have determined using the inclination theta and the y-intercept given. The second question, what is given? Here again, inclination is given. Inclination theta. Inclination theta is equal to 60 degree. What else? And a point. And passing through -2, 5. A point is given. Coordinates of the point are -2, 5. Okay. We have inclination and a point given. We need to write the equation. We will be using the slope-intercept form. That is y minus y1 is equal to m into x minus x1. Okay. Here again, what do we need? We need y1, x1, x1, y1 values. This is what x1, y1 values are. That is the coordinates of point x1, y1. So, we got x1, y1. What about m? What is m? M is slope. We have inclination given. Then we can easily find slope, right? Slope m is equal to tan of theta. Tan theta. Here what is theta? Theta is given, that is 60 degree. Therefore, tan 60 degree. What is the value of tan 60 degree? √3. Correct. Therefore, slope m is equal to √3. Now, we can form the equation of line. Yes. Y minus y1 is equal to m into x minus x1. This is the slope-intercept form. Here, substituting values for x1, y1 and m. Y minus, what is y1? 5. 5 is equal to m. M is √3 into x minus x1. X minus of -2. X minus of -2. That is y minus 5 is equal to √3 into x plus 2. This is the required equation of line when a point and inclination is given. Clear? Now, in the third question, 2 points are given. When 2 points are given, this is your first point and this is your second point, -3, 1, 1, 5. We take them as x1, y1 and x2, y2. We have a formula to find slope. What is it? Slope m is equal to y2 minus y1 divided by x2 minus x1. Okay. So, this is the required line. We are going to determine the slope using the x1, y1 and x2, y2 values. Substituting the values, what is y2? Here y2 is 5 minus y1 is 1 divided by x2 minus x1. x2 is 1 and x1 is minus 3. Minus of minus 3. That is equal to 5 minus 1, 4 divided by 1 minus of minus 3, which is 1 plus 3. 1 plus 3 is 4. So, we got the slope is equal to 4 by 4, which is 1. M is equal to 1. Now, we need to find the equation of line. Again, using the slope-intercept form, we have y minus y1 is equal to m into x minus x1. Y minus y1 is equal to m into x minus x1. So, here we have taken x1, y1 points. Yes. So, we will be substituting these values in place of x1 and y1. We have determined the value of m is equal to 1. That is, y minus y1 is 1 is equal to m. 1 into x minus x1. The value of x1 is minus 3. Minus 3. That is, y minus 1 is equal to x minus of minus 3 is plus 3. Here we have into 1 you will be getting the same value. That is, y minus x is equal to, I am taking all the variables to one side, y minus x is equal to minus 1 taken to the opposite side, 3 plus 1. Okay, that is y minus x is equal to 4. So, this is one form of the equation. Or I am taking all the variables to the other side and the constants to opposite side. Then what do we get? We will be getting this y becomes minus y and x becomes minus x becomes plus x. Therefore, you will be getting x minus y is equal to minus 4. There is a standard form, that is ax plus by plus c is equal to 0. If you are converting to the standard form, here we have x minus y, taking this minus 4 to the opposite side, plus 4 is equal to 0. This is a standard form. But this and this are all correct. Okay. Any of this you can write. So, just remember the standard form, that is ax plus by plus c is equal to 0. You should have the x, you should have the y and the constant here. Clear? So, these three questions here we have solved, where in some questions you have inclination and y-intercept given. The second question you have the inclination and a point given, and third, no inclination or the slope is given. We are determining slope with the 2 points that are given. Clear, right? Let's move on to the next example. Next, example 2, find the equation of the line whose x-intercept is 8 and y-intercept is minus 12. Here in this question, neither the inclination is given nor the slope is given. We need to find the equation of the line. What are the given quantities? We have x-intercept. X-intercept is equal to 8 and y-intercept is given. Y-intercept is equal to minus 12. What are x and y-intercepts? So, let us consider the coordinate axis. Here we have the x-axis and this is our y-axis. Now, I am considering a line which cuts the x and y-axis. This is a point where the line cuts the x-axis. This point is our x-intercept. That is, at what point the line cuts the x-axis. So, when you take this point, it is sure that the y-coordinate will be 0 and the value of x-coordinate will be 8. So, here we have 8, 0. Okay, x-coordinate is 8 and the y-coordinate is 0 because this point lies on the x-axis. Any point that lies on x-axis will be having y-coordinate equal to 0. Now, the second point, that is the point which lies on the y-axis, and this line passes through this point. And here we have the y-intercept. Y-intercept point, when you consider, you will be having the x-coordinate equal to 0. This is y-axis. Any point which lies on y-axis will be having x-coordinate equal to 0. So, x-coordinate is 0 and the y-coordinate will be minus 12. Minus 12. So we got the 2 points. Let us take them as x1, y1 and this points as x2, y2. When you have x1, y1 and x2, y2, we can easily determine slope, right? Slope m is equal to y2 minus y1 divided by x2 minus x1. Now put the values of x1, y1 and x2, y2. We get m is equal to y2. Here y2 is minus 12. Minus 12 minus y1 here we have 0. 0 divided by x2. What about x2? x2 is 0. x2 is 0 and x1 is 8. 0 minus 8. Therefore, m is equal to minus 12 minus 0 is minus 12 divided by 0 minus 8 minus 8. Negatives can be removed. You have 12 divided by 8. That is 4 into 3 is 12 and 4 into 2 is 8. We get 3 divided by 2. Therefore, our slope m is equal to 3 by 2. Now we can find the equation of line. Yes, slope-intercept form. Y minus y1 is equal to m into x minus x1. Substitute the values. We have y1 and x1. We also have the m value now. Okay. Either you can take this point or this point. You will be getting the equation of line. It will be satisfied. Let us take this as the x1, y1 values. So, y minus y1 here we have 0 is equal to m is 3 by 2 into x minus, what is the value of x1? x1 is 8. 8. Okay. Taking this 2 to the opposite side, we get 2 into y. Minus 0 can be removed. Is equal to, removing brackets and multiplying, we get 3x minus 3 into 8, which is 24. Okay. Now, let us bring to the form ax plus by plus c is equal to 0. I am taking this 2y to the opposite side. We get 0 is equal to 3x minus 2y minus 24. 2y becomes minus 2y, or we can write this as 3x minus 2y minus 24 is equal to 0. So, this is the required equation of the line whose x-intercept and y-intercepts are given. X-intercept 8 and y-intercept minus 12. Okay. Got the equation? Yes. Let's move on to the next problem. Example 3. Find the equation of the line which passes through 2, 7 and whose y-intercept is 3. Here again slope and inclination is not given. We need to find. Okay. What is given? A point is given. The coordinates of point. Let us take this as x1, y1. x1, y1 is equal to 2, 7. X coordinate is 2 and y coordinate is 7. What else? Y-intercept is given. Y-intercept is equal to 3. Now consider the coordinate axis. This is x-axis. This is y-axis. Okay. The first point is 2, 7. And what about the second point? At least we need 2 points to get the slope. Okay. Now this y-intercept. Here somewhere you will be having y-intercept. Right? What is y-intercept? The point where the line cuts the y-axis. At the point, let us consider this is our required line. Now at this point, we will be having x coordinate equal to 0. Then we got the coordinates of this point. X coordinate is 0 and y coordinate is 3. 0, 3. So we will take this point as x1, y1 and this point as x2, y2. Therefore, x2, y2 is equal to 0, 3. Now we have the equation of slope. M is equal to y2 minus y1 divided by x2 minus x1. Substitute the values. M is equal to, what is y2? y2 is equal to 3. 3 minus y1. y1 is 7. 3 minus 7 divided by x2 minus x1. That is 0 minus x1 is 2. Which is equal to 3 minus 7 minus 4 divided by 0 minus 2 is minus 2. Equal to. Negatives can be removed. 4 by 2. 4 by 2 is equal to 2. Therefore, we got the slope m is equal to 2. Now, the slope-intercept form y minus y1 is equal to m into x minus x1. Put the values. Y minus y1 is 7 is equal to m is 2 into x minus x1. x1 is 2. Okay, that is y minus 7 is equal to, removing the brackets and multiplying, we get 2 into x, 2x. 2 into minus 2 is minus 4. Taking this to the opposite side, 0 is equal to 2x minus 4, y becomes minus y, and minus 7 becomes plus 7. That is equal to 2x minus y, minus 4 plus 7 is plus 3. That is 0. This is of the form ax plus by plus c is equal to 0. So, the required equation of line is 2x minus y plus 3 is equal to 0. This is the required equation of line whose one point is given, which is 2, 7, and the y-intercept is given. Clear? Now, let us solve more problems from exercise 14C. Here we have the first question. Find the equation of a line whose y-intercept is 2 and slope is 3. Here y-intercept is given and slope is given. Y-intercept c is equal to 2 and the slope m is equal to 3. This is a very easy question, right? What is the equation of line? Y is equal to mx plus c. Remember to write the formula first. First write the equation, only then do the substitution. You cannot directly do it. Y is equal to, what is the value of m? M is 3. Slope m is 3 into x plus value of c. Y-intercept c is 2. So, this is the required equation. Y is equal to 3x plus 2. Clear? Very simple, right? We just need to substitute the slope and the y-intercept in the equation for straight line. That is, y is equal to mx plus c. Next, problem 2, question 2 of exercise 14C. Find the equation of a line whose y-intercept is minus 1 and the inclination is 45 degree. In the previous question, we had the y-intercept and slope given directly. Here, inclination is given. Since inclination is given, we need to first find the slope. What is slope? Given inclination theta is equal to 45 degree. We have slope m is equal to tan of inclination. Tan theta, that is tan 45 degree. What is the value of tan 45 degree? Tan 45 degree is 1. So, we got the slope m is equal to 1. Okay. What else is given? We have the y-intercept. Y-intercept represented by letter C is equal to minus 1. So, when you consider the coordinate axis, here you have the x-axis and y-axis. Y-intercept is minus 1. Somewhere here you will be having minus 1 and the coordinate of this point will be, x-coordinate will be 0 and the y-coordinate will be minus 1. Since this point lies on the y-axis, x-coordinate should be 0. Now, somewhat this will be the line. Okay, we are going to find the equation of the straight line. We have y is equal to mx plus c, equation of straight line. Substitute the values for m and c, where m is the slope and c is the y-intercept. Y is equal to m is 1 into x plus value of c. C is minus 1. That is, y is equal to x minus 1. So, this is the required equation. When you put values for x and y, you should be able to satisfy this equation. Okay. Clear? Then these points will be lying on the same straight line. Okay. Either you can write this as like this or take this y to the opposite side. 0 is equal to x minus y minus 1 plus y becomes minus 5. That is x minus y minus 1 is equal to 0. That is standard form. Ax plus by plus c is equal to 0. Or you can write this equation as, this is also correct, x minus y is equal to 1. This form. This is also correct. Okay. So you have 3 different equations. Just rearranging, we are getting these equations. Clear? Next, problem number 3, question 3 of exercise 14C. Find the equation of a line whose slope is minus 4 by 5 and which passes through minus 3, 4. Here slope is given and a point is given. What is the slope? Slope m is equal to minus 4 by 5. And a point is given. Point x1, y1 is equal to minus 3, 4. Very easy question, right? We have the slope-intercept form, that is y minus y1 is equal to m into x minus x1. Putting the values of x1, y1 and m, here we will be getting the equation of the required line. Okay. Y minus y1. y1 is 4. y minus 4 is equal to m. m value is minus 4 by 5. Into x minus x1. x minus x1 is minus 3. Minus 3. That is y minus 4 is equal to minus 4 by 5 into x minus of minus 3 is x plus 3. Now taking this 5 in the denominator to opposite side, we get 5 into y minus 4 is equal to minus 4 into x plus 3. Okay, removing brackets and multiplying, we get 5y minus 5 into 4 is 20 is equal to minus 4x minus 4 into 3 minus 12. Taking this minus 4x to the opposite side, also taking this minus 12 to the opposite side, it becomes 5y minus 20 minus 4x becomes plus 4x and minus 12 becomes plus 12. Plus 12 is equal to 0. That is 4x plus 5y minus 20 plus 12 is minus 8. Minus 8 is equal to 0. You can keep it like this, or 4x plus 5y is equal to 8. This is also acceptable. So this is the required equation of the line which slope minus 4 by 5 and passing through a point minus 3, 4. Clear? Let's move on to the next problem. Next, problem number 4, question 6 of exercise 14C. The coordinates of 2 points P and Q are 2, 6 and minus 3, 5 respectively. Find the gradient of PQ. What is gradient? We have studied in the previous class, gradient and slope are the same thing. Another name for slope is gradient. Then you have to find the equation of PQ. Third, the coordinates of point where PQ intersects the x-axis. Let us start. Here we have 2 points P and Q. Coordinates of P are 2, 6 and the coordinates of Q are minus 3, 5. So this is the line which joins P and Q. We are going to find in the first question gradient of PQ, that is slope. We will take this point as x1, y1 and this point as x2, y2. Okay. How to find the slope? Slope m is equal to y2 minus y1 divided by x2 minus x1. Just we need to substitute to get the slope. Therefore, m is equal to, what is y2? 5 minus y1. y1 is 6. 5 minus 6 divided by x2 is minus 3 and x1 is 2. Minus 2. Okay. That is m is equal to 5 minus 6 minus 1 divided by minus 3 minus 2 is minus 5. We can cancel this negative signs. Then we get 1 by 5. Slope m is equal to 1 by 5. Now what is the second question? Second question, we have to find the equation of PQ. We have slope m is equal to 1 by 5 and a point is given, that is x1, y1. x1, y1 is equal to 2, 6. We can use the slope intercept form. Y minus y1 is equal to m into x minus x1. Substitute the values. Here y minus y1. What is y1? y1 is 6. Y minus 6 is equal to m 1 by 5 into x minus x1 is 2. That is, taking this 5 to the opposite side, 5 into y minus 6 is equal to x minus 2. Okay, removing brackets and multiplying, 5y minus 5 into 6 is 30 is equal to x minus 2. 5y minus 30 equal to x minus 2. Next, taking all the terms to the right hand side, we get 0 is equal to x minus 2. 5y becomes minus 5y, minus 30 becomes plus 30. 0 is equal to x minus 5y, minus 2 plus 30 is plus 28, or the required equation is x minus 5y plus 28 is equal to 0. So, this is the equation of line. Clear? So, this is the answer for our second question. And the third one, we need to find the coordinates of point where PQ intersects the x-axis. To find the point where PQ intersects the x-axis, consider the coordinate axis. Here we have x-axis and here we have y-axis. So, this line passes through a point and it intersects the x-axis. This is the x-axis. So, let us consider the line. Here we have the point where the line intersects the x-axis. So, in this line, at this point, we will be having the y-coordinate 0. Okay, the value of x we don't know. We are going to find the value of x. So, in this equation, we are going to put y value 0 because at that point, we have the y-coordinate 0 because it lies on the x-axis. Substituting, what we get? X minus 5 into 0 plus 28 is equal to 0. That is x minus 5 into 0, 0. Then we have a 28. Plus 28 equal to 0, which means x is equal to, taking this plus 28 to the opposite side, minus 28. We got the x value. Already we know the y value. So, the point is minus 28, 0. So, minus 28, 0 is a point where the coordinates of PQ, of the line PQ, it intersects the x-axis. Clear? Next, problem 5, question 11 of exercise 14C. Find the equation of the straight line passing through the origin and the point of intersection of the lines x plus 2y is equal to 7 and x minus y is equal to 4. So, equations of two lines are given. We need to find the equation of another line which passes through the intersection of these two lines and the origin. What are the coordinates of origin? Yes, x coordinate is 0 and y coordinate is also equal to 0. Here we have two lines. This is the first line. This is the second line. Here we have the point of intersection. Now another line passes through this point of intersection and through the origin. This is our origin. Let us take the point of intersection as A and origin as B. Coordinates of origin we know 0, 0. Now how to find the coordinates of the point A, that is the point of intersection. What are the equations of the lines? X plus 2y is equal to 7, equation 1, and x minus y is equal to 4, equation 2. So, we know that at the point of intersection, this is a single point. This single point should satisfy both these equations, that is Here we will be getting some x and y values. When you put this x and y values in the first equation, you should get 7. And when you put this x and y values in the second equation, you should get 4. So, how to find these x and y values? We have to compare these equations. So, this is a linear equation in two variable. This is also a linear equation in two variable. Comparing this, you can use the substitution method, elimination method to solve this. Here, what I am going to do is equation 1 minus equation 2. I am subtracting the second equation from the first equation so that I can remove the x containing term. Yes. What do we get in the left hand side? Here, equation 1, x plus 2y minus equation 2. Equation 2, x minus y. X minus y is equal to RHS. Here we have 7 and here we have 4. 7 minus 4. Okay. So, here we have x plus 2y, removing the brackets and distributing the negative sign. It becomes minus x, minus of minus y is plus y is equal to 7 minus 4, we get 3. X and minus x can be removed. Then we have 2y plus y, which is 3y. 3y is equal to 3. If 3y is equal to 3, then we get y is equal to 3 divided by 3, which is 1. We got the y coordinate of the point A. Okay, y coordinate of point A is 1. Now, how to find the x coordinate? Put this y value in the first or the second equation. Equation 1, we have x plus 2y equal to 7. I am going to put this y value in this equation. X plus 2 into 1 is equal to 7. That is x plus 2 into 1, 2 is equal to 7. X is equal to 7 minus 2, which is 5. X is equal to 5. We got the x value. So, the coordinates of point A are 5, 1. We have point A here of coordinates 5, 1. And we have the point B, which is origin 0, 0. Now, what do we need to find? We need to find the equation of this straight line which passes through the intersection and the origin. Here, we will now take this as x1, y1 and this as x2, y2. x1, y1 and x2, y2. Now, we can find the slope. Yes. Slope m is equal to y2 minus y1 divided by x2 minus x1. If you get the slope, you can just substitute the values of x1, y1 and m value in the slope intercept form. y2, what is y2 here? 0. 0 minus y1 is 1. Minus 1 divided by x2 is 0. x1 is 5. That is minus 1 divided by minus 5. Removing the negative sign, we get 1 by 5. M value is 1 by 5. Now, the equation. Slope intercept form, y minus y1 is equal to m into x minus x1. Putting values, y minus y1 is 1 is equal to m 1 by 5 into x minus x1. Here x1 is 5. Now, taking this 5 to the opposite side, 5 into y minus 1 is equal to x minus 5. Removing the brackets and multiplying, we get 5y minus 5 into 1 is 5 is equal to x minus 5. Okay. Taking all this to the opposite side, we get 0 is equal to x minus 5. 5y, taking to the opposite side, becomes minus 5y. Minus 5 becomes plus 5. Now, minus 5 and plus 5 can be cancelled. We are having x minus 5y is equal to 0, which is the required equation of the line which passes through point of intersection A and the origin B. Clear? So, this is your final answer, x minus 5y is equal to 0. Next, problem 6, question 12 of exercise 14C. In triangle ABC, the coordinates of vertices A, B and C are 4, 7, minus 2, 3 and 0, 1 respectively. Find the equation of median through vertex A. Also find the equation of the line through vertex B and parallel to AC. Here we are considering a triangle ABC of coordinates. We have A 4, 7, B minus 2, 3 and C 0, 1. Okay, we got the coordinates. Find the equation of median through vertex A. What is median? Starting from vertex A, cutting the opposite side BC at its midpoint. Where is a point? Let's take D. We don't know the coordinates of D. Okay, so this line which starts from vertex A and ends at the midpoint of BC is the median. Okay, median AD. Here we have taken the median AD. We need to find the coordinates of D. How to find the coordinates of D? D is the midpoint of BC. If D is the midpoint of BC, then we can find the coordinates of D. How to find the coordinates of midpoint? X coordinate. X will be equal to x1 plus x2 divided by 2. And the y coordinate, y is equal to y1 plus y2 by 2. So, the coordinates of D are x1 plus x2 divided by 2, comma y1 plus y2 divided by 2. Put the values. Here, what is x1? We are taking this point, the first point B as x1, y1 and the points of C as x2, y2. Put the values. Here we have x1 minus 2 and x2 0. Minus 2 plus 0 divided by 2, comma y1 plus y2 by 2. y1 is 3 and y2 is 1. 3 plus 1 divided by 2. Okay. Therefore, the coordinates of D are minus 2 plus 0 minus 2. Minus 2 by 2, comma 3 plus 1 4 divided by 2. Or D minus 2 by 2 minus 1 4 by 2 2. We got the coordinates of D, that is minus 1 comma 2. Okay, we got A and we got D. Now we need to find the equation of the median line AD. We'll be finding the slope first. Slope M is equal to y2 minus y1 divided by x2 minus x1. Here we are taking the first point A as x1, y1 and D as x2, y2. We'll consider these 2 points. That is M is equal to, then what is the value of y2? Here we have 2 minus y1, y1 is 7. 2 minus 7 divided by x2 minus x1, x2 is minus 1 and x1 is 4. Minus 1 minus 4, that is equal to 2 minus 7 is minus 5 divided by minus 1 minus 4 minus 5. Negatives can be removed. What is 5 by 5? 5 by 5 is 1. Therefore, we got slope M is equal to 1. We got the slope. Yes. Here we have the slope intercept form to find the equation of line, that is y minus y1 is equal to m into x minus x1. Substitute the values here. y1, x1, y1 we are taking the points A, that is y minus y1, y1 is 7 is equal to m value is 1 into x minus x1 is 4. That is y minus 7 is equal to x minus 4. Taking them to the opposite side, we get 0 is equal to x minus 4. Y becomes minus y and minus 7 becomes plus 7. Okay. That is 0 is equal to x minus y minus 4 plus 7 is plus 3. That is x minus y plus 3 is equal to 0. This is the required equation of the line which is the median AD. Now what is the second part? We need to find the equation of the line through vertex B and parallel to AC through vertex B. This is vertex B and it should be parallel to AC. We'll consider this line. Okay. Now, how to find the equation of this line? Only thing that we know about this line, let us call this some PQ. About this line PQ is a point is given. The point has coordinate -2, 3. We can take it as x1, y1. So, at least we need the slope, right? Now, we also know that this line PQ is parallel to AC. In case of parallel lines, they will be having same slope. So, if you find the slope of AC, you will be getting the slope of PQ. Slope of AC is equal to slope of PQ since they are parallel lines. Now, how to find the slope of AC? That is very easy, right? M is equal to, we'll take these points as x1, y1 and the point C as x2, y2. So, M is equal to y2 minus y1 divided by x2 minus x1. Put the values. What is y2? y2 is 1 minus y1. y1 is 7. 1 minus 7 divided by x2 minus x1. x2 is 0 and x1 is 4. 0 minus 4. That is 1 minus 7 is minus 6. Minus 6 by minus 4. Negatives can be removed. What is 6 by 4? 6 by 4 is 3 by 2. Okay. We get the slope M is equal to 3 by 2. We got the slope. We have point x1, y1. Yes, this is our required point. -2, 3. Now, we can find the equation of line. Slope intercept form. Y minus y1 is equal to m into x minus x1. Here we have a point B. Coordinates of B is taken as x1, y1. So, y minus y1 is 3 is equal to slope. We have determined the slope of AC is equal to 3 by 2. The same will be the slope of PQ. That is 3 by 2 into x minus x1 is -2. -2. Y minus 3 is equal to 3 by 2 into x minus of -2 is x plus 2. Taking this 2 to the opposite side, we get 2 into y minus 3 is equal to 3 into x plus 2. Removing the brackets and multiplying. 2 into y, 2y. 2 into -3, -6 equal to 3 into x, 3x plus 3 into 2, 6. Okay. Rearranging this, taking this 2y and -6 to the opposite side, we get 0 is equal to 3x plus 6. 2y becomes -2y and -6 becomes +6. That is 3x minus 2y plus 6 plus 6. That is plus 12. Plus 12 is equal to 0. So, this is a standard form of the equation of the line which is parallel to AC and passing through the vertex B. 3x minus 2y plus 12 is equal to 0. Here, next problem number 7, question 14 of exercise 14C. Find the equation of the perpendicular drop from the point -1, 2 onto the line joining the points 1, 4 and 2, 3. Here, we have a point P of coordinates -1, 2. And we have a line joining two other points A, B. Coordinates of A are 1, 4 and the coordinates of B are 2, 3. What is given in the question? Find the equation of the perpendicular drop from the point. Here we have the point P onto the line joining the points. This is a perpendicular. Yes, what is perpendicular? It means the line joining at 90 degree. Angle will be 90 degree. Okay. So, we got the perpendicular. Here we have the coordinates of A and B. We need to find the equation of this perpendicular. We will call it some PO. This point, I will take it as O. So, we will need to find the equation of this perpendicular. We know that when a line is given and we have a perpendicular, we can find the slope of the line with the 2 points. After finding that slope, we can find the slope of the perpendicular. Yes. So, by that, we will be getting the slope of perpendicular, and points are also given. So using the slope-intercept form, we can easily find the equation of line. Let us start now. First, we'll be finding the slope of AB. Let us take the slope of AB as m1. m1 is equal to y2 minus y1 divided by x2 minus x1. Put the values. Here I am taking this as x1 y1 and this x2 y2. m1 will be equal to y2. y2 is 3 minus y1 is 4. 3 minus 4 divided by x2 is 2 minus x1 is 1. 3 minus 4 is minus 1 and 2 minus 1 is plus 1. Therefore, we get m is equal to minus 1. Slope is minus 1. Slope of this line AB is minus 1. We have m1 into m2 is equal to minus 1. What is m2? m2 is the slope of perpendicular. So, the slope of the line into slope of perpendicular will always be equal to minus 1. Here, from this we can find the value of m2, which is the slope of perpendicular. m2 is equal to minus 1 divided by m1. All of this we have discussed in the previous class. If you haven't watched, go watch it first. Equal to minus 1 divided by, here we have minus 1 as the slope, m1, minus 1. Okay. Minus 1 by minus 1, we get plus 1. Therefore, m2 is equal to plus 1. Slope of perpendicular we got, that is m2 equal to 1. Now, to find the equation of line, slope-intercept form, y minus y1 is equal to m into x minus x1. Put the values. Here, we are taking the coordinates x1, y1, minus 1, 2, which is a point on the perpendicular line. Y minus y1 is 2 is equal to m is 1 into x minus x1 is minus 1. Minus 1. That is y minus 2 is equal to x minus of minus 1 plus 1. Okay. Rearranging this, we get, I am taking this y minus 2 to the opposite side. 0 is equal to x plus 1. Y becomes minus y. Minus 2 becomes plus 2. That is 0 equal to x minus y plus 3. 1 plus 2 is 3. Or we can write x minus y plus 3 is equal to 0 is one form of the equation. Or you can write x minus y is equal to minus 3. This is another form. Or y minus x is equal to 3. All these are acceptable equations. Just making some rearrangements. Clear? So, this is the equation of the perpendicular which drops on AB. Okay, first we are finding the slope of AB, from which we are finding the slope of perpendicular and then finding the equation of line. Clear? Understood this? Let's move on to the next problem. Next, problem number 8, question 21 of exercise 14C. Write down the equation of the line whose gradient is minus 2 by 5 and which passes through point P, where P divides the line segment joining A4 minus 8 and B12 0 in the ratio 3:1. Here we have 2 points A and B. Coordinates of A are 4 minus 8 and that of B are 12, 0. So, this is the line joining A and B. Now, we have a point P. So, a line passes through AB such that this AB is divided in the ratio 3:1. We don't know the coordinates of this point P. Let us take it as x, y. We have the gradient given. What is gradient? Gradient is nothing but the slope. Slope m is equal to minus 2 by 5. We need at least one point to use the slope-intercept form to find the equation of line. So, this one point is Pxy, which lies on AB, line AB, and it divides AB in the ratio 3:1. How to find the coordinates of this point Pxy? We have studied the segment formula, you remember? Segment formula. To find the x coordinate, we have x is equal to m1 x2 plus m2 x1 divided by m1 plus m2. And y coordinate is equal to m1 y2 plus m2 y1 divided by m1 plus m2. Here what is m1 and m2? m1 and m2 is the ratio. We have m1 is to m2 is equal to 3 is to 1. Therefore, m1 is 3 and m2 is equal to 1. What else do we need? We want the values of x1, y1 and x2, y2. Coordinates of A, x1, y1. Coordinates of B, x2, y2. Now just substitute the values to get x. X will be equal to m1, x2. m1 is 3 and x2 is equal to 12. 3 into 12 plus m2, x1. m2 is equal to 1. x1 is equal to 4 divided by m1 plus m2, 3 plus 1. That is equal to 3 into 12, 36 plus 1 into 4, 4 divided by 3 plus 1, 4. 36 plus 4 is 40. 40 by 4 which is equal to 10. X coordinate is 10. Now, similarly, we will find the y coordinate. m1 by 2. m1 is equal to 3 and y2 is equal to, y2 is 0 plus m2 y1. m2 is equal to 1. y1 is equal to minus 8 into minus 8 divided by m1 plus m2. Again 3 plus 1. That is equal to 3 into 0, 0. 1 into minus 8 is minus 8. Minus 8 by 3 plus 1, 4. Minus 8 by 4 which is minus 2. So, we got the coordinates of point P. P x comma y is equal to P 10 comma minus 2. Okay. These are the coordinates of P. Now, what do we need to find? We need to find the equation of line. We got point. We know the slope. Yes. Slope intercept form y minus y1 is equal to m into x minus x1. Put the values. Here we have x1, y1. x1, y1 is the coordinates of point P. We are taking it as x1, y1. Y minus y1. y1 is minus 2. Minus 2 is equal to gradient or slope m is minus 2 by 5 into x minus x1. x1 here it is 10. X minus 10. Okay. Taking this 5 to the opposite side. Y minus minus 2 becomes y plus 2. 5 into y plus 2 is equal to minus 2 into x minus 10. Removing the brackets and multiplying, we get 5y plus 5 into 2, 10 is equal to minus 2 into x minus 2x. Minus 2 into minus 10 is plus 20. Taking this terms to the opposite side, we get 5y plus 10 minus 2x becomes plus 2x and plus 20 becomes minus 20 is equal to 0. That is the final equation 2x plus 5y. 10 minus 20 is minus 10 is equal to 0. So, this is the required equation of the line which divides the line joining A and B in the ratio 3:1. Okay. With the slope. Slope is given, that is minus 2 by 5. Clear? So, this is your final answer. Here we have the last question for today. Problem 9, question 22 of exercise 14C. A14, B32 and C75 are vertices of a triangle ABC. Find. First question, the coordinates of the centroid of a triangle ABC. And the second, the equation of a line through the centroid and parallel to AB. Consider a triangle ABC. So, this is triangle ABC. Coordinates of A 1, 4, coordinates of B 3, 2 and C 7, 5. Okay, these are the vertices of the triangle. Now, the first question is we need to find the coordinates of the centroid of the triangle. What is centroid? If you draw medians from vertex A to BC, midpoint of BC, then from B to midpoint of AC, and from C to midpoint of AB. These three medians meets at a point, and this point is the centroid. We have discussed in the previous class, you remember? Yes. So let us take the coordinates of the centroid as x, y. Now how to find the coordinates x and y of the centroid? When you know the vertex, you can easily find the coordinates of centroid. X will be equal to x1 plus x2 plus x3 divided by 3. Similarly, y will be equal to y1 plus y2 plus y3 divided by 3. Okay, here I am taking x1, y1 as the coordinates of A, x2, y2 as coordinates of B, and x3, y3 coordinates of C. Now we will find x and y values. X is equal to, what is x1? x1, 1, x2 is 3 plus 3 plus x3 is 7 divided by 3 equal to 1 plus 3, 4, 4 plus 7, 11, 11 by 3. And y is equal to, y coordinates, here we have 4 plus 2 plus 5. 4 plus 2 plus 5 divided by 3. 4 plus 2 is 6. 6 plus 5, 11. 11 by 3. Therefore, the coordinates of centroid are 11 by 3 x coordinate, 11 by 3 y coordinate. So, we got the coordinates of centroid. Now, in the second question, we need to find the equation of a line through the centroid and parallel to AB. So, here we have centroid and the line should pass through centroid and it should be parallel to AB. This is AB. So, a line parallel to AB and passing through the centroid. This is the line. Let us take it as some PQ. Okay. To find the equation of line, we need a point x1, y1. Centroid is a point. Yes, centroid is a point that lies on this line PQ. We have the coordinates 11 by 3, 11 by 3. What else we need? Do we need? We need the slope m. How to find slope m now? Here it is given that this line PQ is parallel to AB. We can easily find the slope of AB. Yes. If the coordinates of A and B are known, then slope of AB m is equal to y2 minus y1 divided by x2 minus x1. Put the values here. Y2. Y2 is equal to 2 minus y1. Y1 is 4 divided by x2 is 3 and x1 is 1. 2 minus 4 minus 2 divided by 3 minus 1, 2. That is minus 1. Minus 2 by 2 is minus 1. We got the slope of AB. Since PQ is parallel to AB, slope of PQ will be equal to slope of AB. Okay. Therefore, we got the slope of PQ as minus 1. Slope of PQ is equal to minus 1. Now, we can find the equation of line. Yes. We have y minus y1 is equal to m into x minus x1. Put the values y minus. We have taken points from the centroid. Coordinates of centroid y1. 11 by 3 is equal to m is the slope and here we have minus 1. Minus 1 into x minus 11 divided by 3. Okay. Taking LCM, denominator we get 3. 3 into y, 3y minus 11 is equal to, here we have minus 1. Again taking LCM, denominator we get 3. 3 into x, 3x minus 11. You can cancel this 3 and this 3. Okay. Removing brackets and multiplying, we get 3y minus 11 is equal to, minus 1 into 3y is minus 3y. Okay. Bringing them to the left hand side, we get 3y minus 11 minus 3x becomes plus 3x plus 11 becomes minus 11 is equal to 0. That is 3x plus 3y minus 22 is equal to 0, or you can write this as 3x plus 3y is equal to 22, which is the required equation of the line which passes through the centroid and is parallel to AB. Clear? That's all for today. In today's class, we have discussed about X-Intercept, Y-Intercept and the various forms of equations of a straight line. Hope you all enjoyed this session and solved many questions from exercise 14C. There are a few more questions which you can solve on your own. I'll be back in the next session. Until then, stay tuned to LearnoHub. LearnoHub free hai, par best hai. Thank you.